Are you leaning like this?
No, but yes,
okay,
but
it
also.
looked like you were leaning like this.
No, but my legs are leaning the other way.
Why? Is this you after the count test?
Yes. And I'm singing very quietly.
Not creepy at all, Mason. We should be.
I think I can answer most questions on this test.
Did we do good as a whole class?
I don't know. This is the first time I'm seeing your
Oh.
grades. But I can answer most of your questions. After Rezo and Sammy left my office Friday, I figured out most
Yeah, I
of
wanted
the...
to go with them, but my bus already left for service, so...
They totally didn't go.
Wait, Rizzo went. Yeah, he went.
Yeah, Rizzo
Really?
went.
He just
And
got-
Sammy went too.
They went on a different bus.
Yeah, they went to a different service
Yeah, 'cause
area.
they're in mine. They got there like slightly late, but it's alright.
Good. I'm
Hey,
glad,
one of us
I'm
like
glad that
broke
Rezo
this.
didn't completely corrupt Sammy.
Why does the book use vectors for describing derivatives?
Say again?
Why does the book use vectors in describing derivatives?
You use vectors a lot. You use them a lot more in Calc 2.
Yeah, it's just,
I do.
I felt like
My
I was
grade
reading my
dropped
physics
7
book over the
points.
weekend.
There's definitely a lot of crossover.
Yeah, because we went over that stuff.
Yes, it is.
Sammy.
I've never met you.
Oh my gosh. Sammy.
I don't know how to handle or
What about 4 years ago?
So, Sammy, after you left Friday, I pretty much figured out the rest of the questions that you asked me. So, if you want to ask again after you get your test back, then I'll know the answers.
Like, this test is a good practice on how to process grief for me.
Oh. Oh.
I've been processing since like when we put them out Friday. Yeah.
Yeah, I think so.
Can you guys hear us over there? Isothermal?
I'm hungry.
Can you hear us, Dale?
That or he's just ignoring us.
Dale, can you hear us?
Both mentally and
They might have us.
I think they're ignoring us on purpose.
They might have us muted.
Ethan. Don't give us all sick.
It's alright, I'll cough on you or
I
something.
don't, please do. I don't want to work this entire week.
It's time.
Reza, what time did you get up?
I mean, my clock kind of screwed up in the morning, and I set like an hour forward or
I
something.
felt really good about this test. I really want to know what I got. I know those two I definitely
Did we get our test back yet, or is it still?
She's still.
Okay.
Stay fully.
Well, I just heard Sammy talk about it, and I thought,
That's because I know I did bad.
yeah, at least, can I switch seats? I just need to be closer to Mason.
And cough on you. And cough on you.
Huh?
Yes, please do. Get Reza sick.
Why? My immune system already sucks as it is. You want me to die sooner?
That's not what I meant.
I realize every time I get
That
sick,
escalated
That's
quickly.
not what I meant.
every time I get
It's
sick,
so
it chips off my lifespan.
Sure.
Either that or I'll make it longer.
Can you hear us now?
Like more immunity to it.
It's on there.
I don't know.
So cool.
Man, imagine if we had an algorithm to calculate your lifespan. That'd be crazy.
Dale, Joe. Where are you?
60.
Do you need to make the text bigger?
40.
I want to make the text bigger.
I saw this Q&A with this one professor, and he was asked what he was doing when he was 20.
Can you hear us?
And he's from like this super
Hello.
trash part of
We can't
Toronto.
hear
He
that.
said, when I was
Are we
25, I
doing
thought my
30
life was halfway over.
Yeah. I heard it was easy.
Because most people are
I hope.
It is. I looked
Because
at it too.
I thought I understood continuity, but I was clearly
Feeling
wrong.
better, Josh?
I think they're just ignoring us.
Oh gosh, we can't even do.
Or maybe they're just being silent. They're playing with us.
Oh yeah, on September
Yeah, the
25th.
cover band is having a function.
Oh yeah, so quiz bowl, am I right? It was awesome. And Miss Africa kept on harassing me to join, and then eventually she was like,
Can you hear us
"Yeah,
now?
you feeling better?"
Okay, yes.
And mentally, no.
I was getting a little worried there for a second.
I was feeling like down from the dumps.
Eventually,
Nope.
she was really
Physical's not the thing, it's the definition.
sign me up. Yeah, it was so funny, dude. There's this one kid on the NBA team that's like, you know those kids have like mustaches? It's not like a stripper mustache, it's like, wow, this is your first mustache, and it's really gross and adolescent, and you just, you know what I'm talking about? It's like, you know, like a chubby head, but not like that, it's just like a giant head. Always really weird, especially in a big icon. Possibly. He was wearing a blue shirt. Yeah, he kept on making like these,
Good for you, Rizzy.
Don't
No.
let me say.
I don't deserve any of
Good
Isn't he just said to find the limit? He never said to solve it.
What a dumb world.
What points did you get? Oh my god. How? I don't know.
Wow.
Oh,
Wow.
Tim was from an
Oh, guys, guess what? If you tried the bonus, you got something.
Wait.
You put
What does that say?
Hey, Carson.
Oh my god, I got
it. Mason.
Just kidding.
Which kid was going to make fun of on the quickball? Which kid were you making fun of on the quickball?
I wasn't. Gosh, I wasn't making fun.
Were you making fun of the villain?
Yes.
Yeah, the villain. We call this one kid the villain because he got all the questions right. When it came to the last question, that if we got it wrong, we would have lost. He was praying really hard.
Which
He was
one
like,
was it?
the kid with the blue shirt. So
Yes,
on the
yes.
last question,
That's the kid that like.
he was just like,
I know there was something wrong
And then
with
I-
him, but he like smiled and like got really excited every time they got a question right, and I was just really happy to see him say it.
and then I told Anna like, you're praying now, I can't beat the villain.
Alice got up in a fight saying that.
Wow, that's mean.
Why would you let? Of course that. Oh my god, I can't stand you.
Rizzo,
Yeah?
what did you get?
I got a number.
Nice. Good job.
Mason, that group chat is not for other people to read. You know,
Let's just say I'm mildly impressed. Let me calculate my score. She took the bait.
Wait, where's the music? Can I borrow that
Yeah, sure.
Yeah, I do know.
after? Can I borrow that after recess?
Yeah, I can take it.
Yeah.
Oh my gosh, Brittany, I'm so
Why?
proud of you.
Really?
Yeah.
Great, good
I'm so proud of you.
I thought I failed. Oh my goodness. Look at that.
I think we did better than we thought we would.
I mean, it's my best score to date. It's not that good, but still, it's improvement.
Dale, what did you?
I'm pretty sure Dale is just like a god among men. Wait, can Dale hear me
Oh, I
right now?
kinda gave up.
Wait, how's that isothermal cover band going? Is it like?
Yeah, I didn't know what to do after I like.
We'll work on it.
Boil it out.
What is this?
So I just wrote down the thing.
That was neat. What was the answer?
That's
Yeah,
what I
it's
did
infinity
for
and negative
these
infinity.
ones.
Oh, there's an A and a B. That makes
Maybe you should have just written it differently.
Oh, he does
And I
have
guessed
yeah.
for that one.
Infinite discount.
Values for
I
the
was thinking about putting it, but I didn't.
And I hate the word cons because like it gets really close
Because
to.
of the. Cause
I have
that
to be very
looks
careful
like
when I
that
say a verb.
one idea.
I've already said a bad one. And I'm not flipped out. Like you literally back.
So I don't understand how you.
I want to be able to do a backflip one of these days. You look like you're trying to be your brother. Wearing a hat. That's cool.
Oh, so you're saying Dylan doesn't own cool hats?
Well, he's not as cool as Andrews. He has a Germany hat, okay? A Deutschland hat. And also he has like really nice gold.
So it's for
Andrew
the-
had
Dude,
hats
there's-
side by side.
So I just guessed that it looked like that function. Or that function.
I think I took this one. That's why it's mine now. Hey, Miss Klinger.
Yeah.
What'd you get for lunch with Miss Johnson Friday?
What did I do?
What'd you get?
Oh, Mexican.
So I
Oh,
plugged
sweet.
in.
Oh, Mexican right after that conversation.
I really wanted a chicken parmesan.
And then I kept.
I told her what my like income goal is in the future. That I'll make an income where I can get chicken parms every other day.
Oh no.
If I can get chicken parms every other day and have like, I don't know, like a maid clean up my house.
Back to the pure beats.
Also, I'm okay, like, you know, living in like comfort. But I think this is gonna kind of overflow you slowly, but.
Joe Reza, that guy said that our judge was unfair.
Okay, there's a couple of them.
Who said that
The big guy, his name was Ash.
The kind of huge dude that sat directly across from me.
Oh yeah, the face dude.
Yeah.
Why did he say that there's I mean, they got the easy questions. They got like what, they got like what black rock is used for fuel.
Coal?
Basically, we had this
We'll
Hispanic
get started.
Yeah. Dude, we got like we had like this Hispanic so it's time to start
Like a higher reading or Basil and Lee switch seats.
What did he say?
So we switch seats.
Switch or have switched?
Have switched, is that right? That's fine. You don't have to switch that. I'm making sure I'm doing this. What shows up on the TV isn't as clear as you might think it is. It's kind of fuzzy.
He's so handsome.
You need a big name tag. Reza's going to throw out a big name tag. Okay. So you should have your test back by now. Overall, the test went reasonably well. Some issues. A couple comments. Number 4 was one that a lot of people had trouble with. Then, factoring out an X on number 4 doesn't really help. Let me just make a comment on that. Let's go right here. On number 4, you can factor out an X. So limit X goes to 1 of 1 minus X over, what is it, square root of X minus 1? Square root of X minus 1. And some people say, well, let me factor out an X because this is indeterminate. If you plug in a 1, you're going to get 0 over 0 indeterminate. So some people say, well, let me factor out an X. We've done something like that before. And that's fine, but it doesn't really help you here when you do that. So if I factor out X, what does that give in the denominator? 1 over the square root of X, I guess. When you do that, the X's can cancel because they're not 0. That's true, but what do you still get when you let X be 1? You still get 0 over 0 indeterminate. So that doesn't really help you any. Can't, the numerator of number 4 can be seen as the difference of squares. This 1 minus X is equal to 1 squared minus square root of X squared. And therefore, it can be factored. Number 5, we did one just like in class. Number 7, also one like in class. Number 7 involves the definition of number 8, you can factor out an e to the x out of the numerator and denominator. I'm sorry. Number 8, factor out a 3 to the x. 3. 9, 10. We're going to get on those. Mostly 11. I was impressed how many kids got 11. We never did anything like that in number. So that was good. That was what I thought I would miss. some people didn't do a really good job of explaining why it's applicable. If you got in there something about the function is continuous, then I said, okay, you at least hit it, and I gave you credit. One or two people actually referenced why you know it's continuous. I mean, the theorem requires continuity of the function on the interval to be applicable. But how do you know the function that's given on number 12, how do you know that function is continuous? Some of you said it is. I said, okay, I'll give you credit. I give you full credit. But how do you know it is, in fact, continuous? I'm asking you now, how do you know?
Rhetorical? Or is this actually?
Continuity of algebraic functions theorem says that all algebraic functions are continuous on their domain. Well, this function domain is all real numbers, so it's continuous on all real numbers. Ergo, it's continuous on the interval from -1. We clear on that now? So that's really what should have been put down as why it's out. Okay? It requires continuity, and in fact, it is continuous because blah, blah, blah. Not just simply it is. But I get credit for simply it is continuous. Similar for part B. Bonus 1 is in the book. Bonus 2 we did in class is also in the book. And bonus 3, I was going to mention briefly up here. The reason I'm going to mention this is for your extra credit rework that's available for this test as well. The rules are, again, any problem that has a point value to it, so any number problem, for example, number 12. If you didn't get all 16 points on number 12, then you need to do all of number 12 over. Even if you got part D right, you still got to redo it. Are we clear on that? Now, the bonus questions are also required. So if you didn't get all 5 points on each of the bonus questions, and no one did, you have to redo all of the bonus questions as well. Are we clear on that? Okay. So the third bonus is right here as a starting, because that's not in the book, but it was bonus, so I didn't feel bad about it. So if I start off with the general rational function, like I gave you on the test, you try to plug in x goes to infinity, you get the determinant. So one game that we did, let me reference you to, before we go too far, problem number, on the same test, problem number 6. If you look at problem 6, if you got that correct, you should understand what's going on here. It looks very much like this. So if I factor out the highest power of the denominator, x to the m, I could do either one, but I'm going to choose the denominator. What's that going to give me in the denominator? If I factor out x to the m, what's that going to give me? Oh. Is m plus that's e sub n minus 1 times what? Or divided by what? Divided by x. I like to divide by x.
What's he saying? What's he saying?
How do you get divided by x?
How did I get it divided by x right here? Originally I had this. It says b subscript n minus 1 times x raised to the n minus 1 power. I factored out an x to the m, and I'm asking you now, how did I get b sub n minus 1 divided by x? What? Explain that. Simple algebra question.
Wouldn't you have an x to the negative 1 power, which would be 1 over x?
That's why.
Exactly right. You factor out an x to the m, you're dividing by x to the m, so when you subtract m from m minus 1, you get an x to the m to the negative 1. Is that Sammy? Is that right?
Yes.
Sammy, is that you? Excellent, yeah. When you factor out x to the m, you're dividing it out. And so when you subtract the n power from this n minus 1, you get negative 1 power, which puts it in the denominator. And so on the rest of the way across. The last term is going to be b sub 0 divided by x to the m. Follow all that? Why is the last term b sub 0 divided by x to the m? You factored out an x to the m, and there was an x to the, you could view this as, if you wanted, you could view this as x to the 0 right there. And when you factor it out, you get left with x to the negative m, which goes to the denominator. Okay. We'll come back to the numerator. Let's keep going on just the denominator from that. So since x is nowhere close to 0, then I can simply cancel these off. This can be canceled because x is not anywhere close to 0. And on the next step, what do I get on the denominator? Well, let's take off the limit. We'll take a couple steps here, and then we'll begin. Okay, I've done the limit. Now, what happens on all these terms on the denominator? If you do the limit, let x go to infinity on these individual terms on the denominator. What do you get? Just b sub m, and the rest will just be zeros. So in the end analysis, it all comes down to what happens in the numerator. So, well, understand that. I just look at the denominator. If I factor out x sub m, I'm going to force the denominator to only be the lead coefficient. Now, it all depends on the numerator. And you got 3 cases. What were the 3 cases in that theorem? I want to ask them, folks. This is a pre-calculus question. This isn't calculus.
I can't understand what he's saying.
Okay. If the power in the numerator is equal to the power in the denominator, case 1. Case 2 is the numerator is bigger than the denominator. Case 3.
Oh, he's talking about the.
I look at all 3 cases of that. And what happens? Well, before we get to that, let's see if we can figure out what this is going to look like right in here. What's that going to look like?
A sub n.
That's going.
Plus.
Plus, not yet. Not yet.
Not yet.
X to the n minus n. What is not? I've got it's too small to read. Understand how I got x to the n minus m? Sammy, one more time. How do I get x to the n minus m? You told us a moment ago.
You would factor out the m, and then you'd be left with
Dividing by x to the m, and when you divide by x to the n, you subtract the exponents. So this is going to be plus a sub n minus 1 x to the, what power am I going to get there, folks? N minus 1 minus m. That's right. What's the last term going to look like?
A sub 0.
Over x to the m.
X to the what? Well, it's Monday morning, folks, but this is really all this algebra I'm asking you here.
Would it be x to the negative m power?
Yes, yes.
Sammy's on.
How'd you get that again? One more time.
You would just subtract the m from it.
You can envision that as being x to the 0 power if you like. X to the 0 power is 1. Okay. So now that's where you're going to have three cases. What happens with these terms depends on the relationship of n and m. Are we clear? So you would do like case 1. How about let's do n is less than m. What's that going to mean? N's less than m. If the horizontal asymptote equals 0 according to the theorem, you're right, but I'm trying to prove that. So what do I have to look at? I have to look at the exponents. So if n is less than m, what do you know about that exponent right there? It will be negative. So you're going to have, if n is less than m, then this means that n minus m is less than 0.
What does that mean?
Make sense?
Mm-hmm.
And n minus 1 minus m is going to be even more less than 0. And m minus 1 minus m is even more less than 0. And negative m is less than 0. So what I'm seeing is that all of my exponents will be negative when I get to there. What's that going to mean? Negative n over some x value, and we'll a this over an x value. And then when those x values go to infinity, what happens? They're all zeros. So this, if you take all this, you can say that the numerator now goes to 0. And then you do each case to see what happens. Case 2 would be n equals m. Case 3 would be n is greater than m. From that, by each of those cases, you should be able to examine what goes on in this numerator. And from that, you should be able to determine with the limit, applying the limit, you should be able to show what the theory says, which is what you learned in pre-calculus. And you have certain types of horizontal asymptotes under certain conditions. And you're proving that by looking at the limit as x goes to infinity.
Isn't there no horizontal asymptote if n is greater than m, though?
I'm sorry, what's that again?
Wouldn't there be no horizontal asymptote if n is greater than m?
Yes, that is correct. You don't have to show that on here.
Why is that a case, then, if it's the horizontal asymptote theorem? Wouldn't that be
Well,
like
isn't
the...
it? I mean, I get what you're saying, but the book said if you consider the relationship, there's only by oh gosh, I can't come out now. The trichotomy theorem or something? There's only 3 possibilities. Either n is less than m, or it's equal to m, or it's greater than m. Those are the only 3 cases we have. So, granted, n greater than m is not a horizontal asymptote, but that's also spelled out in the theorem. The theorem saying you don't have one. And that's okay for a theorem to tell me when I don't have something. Right? It's like being told I didn't win the lottery. Of course, some people think that not winning the lottery is like losing $1 million. Did you have $1 million in this place, or did you just not? Anyways, the theorem does tell you one case where you do not have horizontal asymptote. That is correct. Okay, so you need to do all of work, and we'll make that due Thursday. So we got a lot of time to get that done. If you're going to do it, you don't have to. It is extra credit. Any questions on your extra credit? You follow the directions carefully, which includes copying the question, the graphs, all that kind of stuff. Has to be copied on any problem that you have to redo. And a problem is numbered, and the parts are all part of that problem. Okay, next up. I give them a choice. I need some good guys up here. Well, it's just, it's heavier than I'm ready for. I might hurt my back, so. Yeah, move back this desk up a little bit.
Make sure it's not nailed.
I don't think it's nailed. I think it's just heavy. Oh, it's not nailed, I'm just.
Well, some of our furniture is nailed down.
Oh, it is, yeah. Okay, so we're ready to start on the next block of material, which is chapter 2, part of block 4. I'm not going to immediately jump into the textbook. I want to approach it a little bit differently to start with. Do y'all remember when we started all of this way back when, on the start here now, when we did Galileo dropping the bowling ball and we found the speed of that? Galileo dropped the bowling ball from 100 feet. So this is height. And then this might be time. We did this. I don't need to repeat the whole ball. This is 2.5 seconds. This is 100 feet. Y'all remember all this? Okay. And we found the speed right at impact. Y'all remember doing that? We took intervals. We found the slope of the line between 2 points. We did like, I don't know, I think 2 seconds or something. 2 seconds, 5. That gave us a straight line. And then we shortened that interval a little bit. We found the slope on the interval 2 to 2.5. And then we did it again. We repeated that. And we made a smaller interval. So then we did the slope on 2.4, 2.5. And then we did the slope on 2.45, 2.5. We did that. We made a table. I remember we made some kind of a table. And that's how we introduced the idea of limits. Well, I'm going to take that idea now and talk about what's called derivatives. So the slope, we all agreed that this slope value was the speed of the ball as it was falling. So I have a position function. So we call this a position function. We call it h for height. In general, position function is named with the letter S. S stands for space position, so that you can take into account 3 dimensions. Right now, we're only going to deal with 1 dimension. It's the ball problem. We'll go to 2 dimensions and 3. The speed of the ball falling, actually, this is not speed, it was velocity. Let me take a look at that. Velocity versus speed. Velocity, we're going to use the symbol V of t. And V of t has a special relationship. Velocity, when we went through all this, we were using, when we calculated slope, how do you calculate, let's just remind ourselves, how do we calculate slope? Way back, this has been 2 weeks ago. How do we calculate that slope? Let's remind us that.
Is he asking a simple question?
Yes.
Simple question, how do we calculate that slope?
The change of y over the change of x.
Yes. So this slope, all of these slope numbers, like we had some interval and we calculated the slope. And we just did change in y over change in x, which was calculated as, for example, on this first one here. But if I look at the first one, it would be the position at time 2.5 minus the position at time 2 divided by the change in my x, y dimension. So that's a time interval of 2.5 minus 2. So position at 2.5 minus position 2, that's the total distance I moved. And this is the total time it took to do that. And that gave me a speed between those two times. Actually, a velocity. Why? What's the difference? I've said velocity, speed. Okay, so this would be the velocity. We call this the average velocity across interval 2 to 2.5. Now, I got to be real careful about terminology here. Average velocity. We want to talk about just velocity itself. This is average velocity. This and this are related, but they're not identical. We're trying to get to velocity from these ideas, and the limit of all of this, the limit as delta x gets close to 0, as the width gets small, that becomes velocity. And this will be called instantaneous velocity. Instantaneous. Instantaneous. So we have instantaneous velocity involves the velocity at a particular time, one time. The average velocity is simply a slope across an interval. And that's a distinction there. This slope across an interval, like we did here, we call this line, this red line here, is called a secant. So the secant line has a slope that we can calculate because you have two distinct points on the curve, two distinct points. And we can calculate the velocity across that interval with those two distinct points by just simply doing change in y or change in x. We call that average velocity. But what we achieved with this table, when we looked at the table and we said, as x went across this way, we said as x got close to 0, we saw a slope value that was getting close to, and I think it was 80 feet per second. Actually, it was negative. So this slope down here, as you get real close, is a very steep slope of negative 8. So that's called instantaneous velocity when you do limit is average velocity when you just do 2 points and calculate across that. All that is great terminology. A couple other things I want to mention, then we'll do some more kinesthetic look at it. Velocity, the symbol V of t, is when you do an instantaneous velocity. Velocity, if I don't give you the adjective instantaneous, if I just say velocity, then I mean instantaneous velocity. If I want average velocity, I've got to say average velocity. If you just say velocity, now without an adjective, then it's interpreted as instantaneous. We'll put on that. So velocity and instantaneous velocity are one and the same. Average velocity is a different piece. They're related. What's the relationship? One more time. We just went through it. What's the relationship between average velocity and instantaneous velocity?
Instantaneous is the velocity at a point, and average is on an interval.
Correct. Instantaneous velocity is the speed velocity at one point, and we achieve it by letting the delta x get close to 0. When it goes to 0. Average velocity is the slope across 2 points. Okay, good. one other thing, when we talk instantaneous velocity, then we can relate this to something called a derivative. We're going to say that, well, it's right. This symbol here, you read this as S prime of T. That's how you read it. So that symbol is going to stand for something we'll learn about here called a derivative, and also called differentiating. And notice, so this is called the derivative. This is called the derivative. And we achieve the derivative by differentiating. And I will emphasize the idea of differentiating, the word differentiating. You should see that you have some differences going on in here. And why are those differences in there in the first place? Find the change in y and x. That's correct. So the derivative is found by differentiating, which involves doing differences, and then taking the limit as delta x. The change in x goes to 0. This symbol, one more time, is called, you read it as S prime of T. That's not a 1 power. It's slanted like almost like an apostrophe. Okay, that's just kind of a quick overview of it. One more thing that we can add in is acceleration. So velocity has its own derivative. That's called acceleration. This is symbol A of T. And acceleration is the derivative of velocity. Okay, let's make sure we're understanding this. So, have a position function. We're going to go one more time real quick. Position function is S of T. We have a velocity function. It's V of T, which has another name called S prime of T, which is called the derivative. So just kind of summarizing all that quick kind of bubble thinking there in your notes. So V of T is equal to S prime of T, which is the velocity. What does that tell me? This is the instantaneous rate of change of position. Note speed is equal to the magnitude or absolute value of V of T. I'll come back to that in just a second. I want to finish the linear notes here. Acceleration is A of t, which is the derivative of velocity. Since velocity is the derivative of position, then we sometimes also say that acceleration is the second derivative of position. So I went on that. Let's see. So this is read as S double prime.
No one at prime. It's prime time.
On the second derivative. Or maybe we're prime time. Maybe we're the not quite ready for prime time players. I know someone who knows that. Why way back in the day.
I'm not fascinated.
Yes. Okay. So this is just kind of a summary of what we just kind of were bubble thinking over here. One comment on speed versus velocity. Velocity gives me the actual rate of change of position. For example, over here, way back over here, with Galileo, the velocity of the bowling ball was negative 80 feet per second. That negative indicates not only the 80 tells me how fast it's going, but the negative tells me what direction it's going. Okay? But speed is the absolute value of velocity, so all it tells me is how fast I'm going. It doesn't tell me what direction I'm going. You know that? What I want to do next is let us get some, I'm just going to erase this real quick. Let us get a feel of this kinesthetically, rather than just doing algebra. Let's see if we can.
We talking kinesthetics now? I'm playing dumb. You're getting straight conceptual.
Well, I'm gonna walk here in a moment. This time, I'm gonna draw what I would consider a one-dimensional map. So I'm gonna do what's called rectilinear motion.
Rectilinear?
Rectilinear, meaning up. Let's not be totally sophomoric here. We are in college now.
How do you say?
Quit being a
I don't know, what did you say? Did you say rectal linear? Were you trying to be funny?
No, I said rectilinear. I did. I don't know what you guys are saying.
Okay, rectilinear motion. That means we're going to be moving in one straight line. We're not going to do it two directions. And I'm going to have a starting position.
Yeah.
Question, I'm sorry, question?
Yeah.
Oh, sure. Pan the camera over small. You need to pan your camera over small. To the right or left.
Thank you.
I'll see you now? Okay.
Yeah.
So this is time, actually I'm not going to do time on here. This is going to be, I'm sorry, apologize. This is going to be positions. This is S, position. Time is going to be embedded into this. And I'm going to start my walk back over there at the edge of the board. And so this is, position is from left to right, and positive direction is to the right, negative is to the left. And I want to see if you can tell me how to walk this walk. So I'm going to start here. Let's see. I'm going to walk.
Joe, we need to zoom back on the board.
Back into the board a little bit. I'm sorry.
Yeah.
And then we'll pan out for a walk in a moment. Okay. So I want to walk. And then I'm gonna be going this direction. And I'm gonna do that. That's this direction. I'm gonna do this. I'm gonna stop right there. So let's say this is speed time equals 0, speed time equals
10. Please 10.
3, speed time equals
4.
5, speed time equals 6.
Oh.
So what do you think about that? If I'm going to walk that walk in a straight line, you know, we'll stand there and do one of these things on one foot. So we're going to stand. We're going to try to walk this walk. So describe for me, how do I need to walk this walk? And I'm going to let y'all do something too.
Well, I think it'd be helpful to see you first.
You want to see me do what?
I want to see you.
Describe that? Let's talk about it a little bit. So if it takes 3 seconds, it looks like it takes 3 seconds to walk from over there about halfway, let's say across the room. And then I've got to go backwards for 2 seconds, and then go forward 1 second and go a good distance. So what do y'all think about that? Let's see.
Oh no, what?
Over here now.
You can't miss it.
I need to see
camera.
this.
Let's see this.
Please.
I don't think I can do it. So I got to do 3 seconds.
Okay, here we go.
2, 1,000, 3, 1,000. 1, 2.
Whoa.
2.
1.
Oh, dang. Oh, yeah.
Did I make it? Almost. So what would you say about, notice the red arrows I put in my graph? Those red arrows are indicating what direction I'm traveling.
Mm.
That would indicate the velocity. Okay? So red arrows are velocity. What about acceleration? What do y'all think about that? This is the hard one. Well, I've got my velocity was positive, meaning pointing to the right, because I was increasing my position. Then my velocity was negative, pointing left, because I was decreasing my position. And then velocity was positive, pointing right, because I was increasing position. But what about acceleration? Well, I had to accelerate. I'll put it double arrow in case you don't have 2 colors. So I had to accelerate to get going, right? Think about this, folks.
What's he asking?
What about Galileo? What happens on that rock with Galileo, the bowling ball? He drops the bowling ball, what happens? Accelerations always happen. And so it's getting faster, faster, faster.
Mm-hmm.
What about me? Was I getting faster, faster, faster the whole time? No.
No.
So I started off a little bit faster, and then I had to come to a stop. That means I put the brakes on. That means my acceleration has turned the other direction. If you keep adding acceleration, you're going to keep getting faster. So I decelerated. So at some point in time, I had to turn my acceleration around backwards so that I came to a stop. Do you understand that? So notice my green acceleration arrows are pointing backwards, meaning I've got negative acceleration, or we call it deceleration. So this is positive acceleration. That is negative acceleration.
Can you zoom in a little more?
Acceleration is also called deceleration.
Oh, that's good.
Now, don't get confused, even though this is really confusing stuff. Negative acceleration does not mean you always slow down. Depends. Okay? So now what happens? So I come to a stop at 3 seconds, and I have to go backwards that way. So I have to add some acceleration.
Backwards.
I still have some acceleration going that way. Get me going. This time, I've got negative acceleration, which is called deceleration. but it actually made me go faster. Went from a stop to going backwards. Then I had to go to a stop again. So what did I have to do? I'm going backwards. I have to come to a stop. That means I have to put my acceleration that way again. So I have to change my acceleration direction this way to bring it to a stop.
Oh my gosh.
Then I have to accelerate heavily in that direction until I end of time. I wish we could hear their funnies. I really do.
I'm sorry, I just saw a passerby
Walk by.
like just look in really curiously.
Oh yeah,
In
yeah.
the hallway, yeah.
Well, that's fine. You gotta invite them in. Maybe they would enjoy it too.
Yeah.
They're
Good
excited.
thing is they don't see you walking.
They
back
don't
and
see me
forth
going
and
crazy.
trying to keep your camera off you.
On one foot, hopping like this.
They're
So,
missing out
They are.
on the best kept secret of isothermal.
What I want you to do now is to think about this. First of all, how would I graph, if I had to graph that as a two-dimensional function instead of a rectilinear? So notice, in rectilinear, the hard part is I'm only walking in one line. So drawing it, I have to embed time into the process. But what we all often do is draw it as a two-dimensional. So what would this graph look like? I put time on the horizontal axis and position on the vertical axis like you're used to seeing. What would my walk look like now? So this to me looks just like the walk. But now I want to think of it in two dimensions because it's easier to think that way sometimes. Yeah. I mean, so I started at the zero position, right? No, draw a picture. Well, it's got to end at time 6. That's what that says to me. What do you think that picture is going to look like? I draw it in 2 dimensions.
Oh my gosh. Well, you want to put a midpoint because that's where things get like weird with the acceleration, like a T of 3.
Okay, so about T3, something's happening at T3. Also, something seems to happen at 5. Let's do.
That's good. That's really good.
Yeah, at time 3, so we took off and we sped up to time 3. We came to a momentary pause. Then we started accelerating down a little bit. Then we came to a momentary pause. And then we really speeded up. Stop. Right? So do we have a volunteer to walk now? I give you a different picture.
Raisin.
No. I
Herb Rezo wanted to volunteer. Now that means
Did he say Reza
that
wants
means
to?
that first row, you're all going to have to stand up and move and get your chairs out of the way so he can walk right there so we can see him on the camera.
Everybody push your chairs in.
Wait, that's interesting.
Alright, we're about to go back.
I don't even know exactly what I'm trying to visualize here, but
I don't either. We'll figure it out.
okay.
Maybe start over there.
I can't even see myself in the camera.
Can you,
Here, you want to see
Amanda,
yourself?
can you zoom back a little bit, Amanda?
Okay.
Is it coming back any?
No. That must be as far as it can go.
Yeah.
Okay, so just put on your ninja outfit there so we can.
We can see.
Now I can see. Yeah, put on your blindfold. That's even better. Now we'll really get it.
Okay.
Start right behind. Reza, start right behind Elise. Move forward, just there, right there. Oh, there you go. Hey, the outlaw, Reza the outlaw. Okay, Reza, what I want you to do, I want you to emulate. I'm going to shoot an arrow straight up into the air, and it's going to go up and it's going to come back down. So what would that look like as a walk?
To jump or to walk?
Walk.
So you want me to like?
Right?
So
Like I
I
did.
run fast, then I slow down, then I go again. Sorry, I'm sorry.
No,
No, I don't think that was right. I heard several no's. You got no'd right away on that one. Let's try again.
I don't know. Okay.
Hey, don't start. Now, who said no? I heard 2 or 3 no's.
Chloe.
Chloe, please tell us what he should do on his walk, and then he'll do it. Don't sit down yet. You're not done. Okay, Chloe, please tell us what Reza should do for his walk.
You have to go backwards at some
I
point.
have to go backwards.
Yeah, because you're
Yeah, because you
decelerating.
go
Oh my gosh.
fast.
So I
Be
slow
more
down.
precise on describing it. You're right. He has to go backwards. Give me more detail on describing that.
The arrow's gotta come down.
Yeah.
Yeah, so speed
Up.
You gotta speed up about
slow
halfway.
down.
Slow down a little.
So
and
you
then
have
I
to go like
go
halfway,
backwards.
and then you have to slow down and come backwards, and then you have
Okay, I'm
to
gonna have to move
go
this.
the whole way. Even
Okay, so we're shooting an arrow. Ready? Straight up, go.
Slow down.
Is that good enough?
Yeah!
I don't know.
That was exactly right. So you had to be going faster at first, slow down and stop, and then start slowly, and then get faster. So
Can I sit down?
as a 2-dimensional graph, what would that look like?
it would just look like a.
Reza, sit down.
Yes, you may sit down now, Rezo. Thank you.
Sit down.
Excellent participation. We'll give you 2 brownie points there.
Oh,
Now
yeah.
tomorrow, everyone's gonna have to do it tomorrow, so don't get complacent yet. What would the 2-dimensional graph of
Wow.
Rezo's walk look like? Yeah. Nice little graph. Okay, good. What would the 1-dimensional, if this is position, and I do a 1-dimensional graph with time embedded, what would my 1-dimensional graph look like? So we got 2 different ways of viewing the same information. Yes. So we just start here, and then it would turn around and come back. Good. This would be, we'll say this was time 0, and can we replay the video and get the real time? No, let's say, yeah, let's say the final time was,
We somebody recording on the phone, so maybe.
oh yeah, who recorded that on the phone? Are you gonna post that for us? We wanna see this.
Sammy did it.
Sammy.
Post it
You
on
should
the
say-
forum, okay?
Yeah, post that on the forum for us. We wanna see this.
Okay.
We need to start a Rezo meme here.
I already
Okay,
have highlights of like lectures. It's pretty crazy. Every time I made you laugh, it's pretty awesome.
So where am I posting the video?
What about my velocity arrows, folks? Velocity arrows are this way, back. What about acceleration arrows?
No.
At the beginning, acceleration arrows in that way. Where backing up. We have to turn them. We have to turn the arrows the other way because we got to stop that velocity. The reason that arrow comes back down is gravity. The acceleration is causing it to slow down. But now, really, is this right? Think about that arrow.
Oh dang, it's not right.
Because you release it, which way is the acceleration happening on that thing?
It's just a
Oh, it's always
gradual
going down.
ramp.
On this arrow, it's always going down, the acceleration.
It doesn't get any faster when you shoot it. It's fastest when you first launch it. So it just very slowly gets slower.
Yes.
It's not very slowly.
I can get
Well, you know,
slower at speed drops by 32 feet per second every second. That's how acceleration works. Okay, good. What about
It's always.
we need another volunteer.
This is measuring its acceleration. So as soon as you shoot it, that's.
Rezo.
Yes?
You volunteered so well. We'll let you pick the next volunteer.
It's not gonna be you, okay? Yeah, Sammy, let's do it, Sammy.
Oh! We know how that works.
What am I volunteering for?
We didn't even consider Mason. Well, it's because you're the SGA president. You're our class
Gotta
representative.
represent us.
You gotta represent our rector.
That's isothermal.
The early college. This is DCCC.
No, this is isothermal, okay?
That's isothermal.
I'm an honorary isothermal.
Reza was the student that walked.
All right, we'll see if we can't get you an honorary isothermal T-shirt or something.
Just me.
Okay, what I'm gonna do is give you a couple minutes to help Sammy. Now that includes ICC folks. Y'all aren't off the block yet. Look at the graph carefully, read all the information provided on the graph carefully, then help Sammy understand how she has to do she's got to walk the walk. Somebody's got to talk the talk first.
It's accelerating. But it starts in the negative.
I'll see the graph.
Velocity.
What? Velocity is your speed. The absolute value of your velocity.
Basically, you go faster.
You started to jog and then you start sprinting.
It's the
But dog,
They have to
walk
see
over.
I don't see it slowing down.
You see it there. And we're going to make a walk. Hope you don't embarrass her.
Start
And then you
fast
flip
backwards.
around and then you.
Fast
You
backwards,
just walk
slow
backwards.
backwards, stop, slow forwards, fast forwards.
I don't buy it.
If you start at Mason and walk backwards to me,
Would
and
I
then take a
end
wall
at the same
forwards.
point though?
Oof.
You would end up here.
Where am I starting?
Mason,
There.
behind Mason.
Yeah, start behind me.
Okay, so I'm gonna walk backwards
Yeah.
Towards me.
and then walk all the way back.
It's like
in.
walk fast backwards,
But
slow
you have
backwards,
to get
slow
faster.
forwards, fast
But it's
forwards.
constant.
Yeah, it's constant.
Okay, never mind, you don't have
So velocity.
It's always increasing.
What is negative velocity? That's the true question.
That's why she's going
Negative
backwards.
velocity is when the direction is
Direction
the opposite.
But if we're talking about absolute value of velocity, that means that even if you're on the lower part, you're still going faster.
Yeah.
Yeah, which is why you go
The
fast
negative
forward
just
at the
means the
beginning.
direction.
So you just go like, woo. Right? That's basically
So,
it.
Pushing me.
there's some discussion about velocity versus speed. Again, speed is the absolute value of velocity, and that only tells you how big the number is, how fast you're literally moving. Velocity tells you not only how fast you're moving, but in which direction you're moving. So, for example, on Rezo's, this red arrow here at the start indicated a positive velocity because it was pointing in the positive direction. And this red arrow here indicated a negative velocity because it was pointing in the negative direction. Increasing position, we call that positive velocity. Decreasing position is called negative velocity.
Insecure. Oh, increasing. Increasing position.
Me?
The position is insecure.
I'm insecure.
Insecure.
I could just do more simply, instead of writing positive velocity, I could just say V straight to 0. Decreasing,
Increasing.
V is less than.
Decreasing. Means I'm hungry instead of me.
You have a special word for increasing position.
Acceleration? Please, please.
No.
No?
Advancing. Wow. Is this military history?
Why? Razor, you said accelerating, and I said no. Let's think about that now. Does increasing position require acceleration? No. For example, I will increase my position without accelerating.
Oh, dang.
Yeah.
I was moving and changing my position, but I was not accelerating. Are you clear on that?
Yeah.
Okay?
Yeah.
When we are decreasing our position, we have a special word for that. Okay, turns go way back time. What do you do if you are running into trouble in battle? You retreat, right?
Oh my gosh, it is military history.
Now let's talk about, before we do this graph, let's talk about speeding up and slowing down. So some more terminology.
Very satisfying. Spinning up.
Speedy.
Speeding.
Think about that now, folks. When I talk about speeding up and slowing down, I'm not talking about velocity particularly. I'm talking about how fast I'm moving. So I'm speeding up this way, but I'm also speeding up that way. I'm slowing down this way. I'm also slowing down this way. So speeding up and slowing down doesn't have anything to do with direction. But it does have to do with velocity and acceleration. So when I'm going forward and I wanted to come to a stop, I'm going forward, I wanted to come to a stop, what did I have to do? Now, what did we say about acceleration that made that happen? You had to decelerate. You had to counteract this motion so that it came to a stop. Okay? What if I wanted to speed up going that way? I want to speed up going that way. I gotta add some acceleration to get my velocity up, right? This way. So think about that one more time. If I want to speed up going that way, what do you got? If I'm going this way, my velocity arrow is pointing this way. If I want to speed up, what do I got to go faster? What's I going to take? Which way is my acceleration point? Same direction. If I'm going backwards, my velocity arrow is this way. I want to speed up, which way is my acceleration arrow point? Same way. Okay. If I'm going that way and I want to slow down, my velocity is this way, but I want to slow down, which way is my acceleration? That way. If I'm going that way and I want to slow down, which way is my acceleration? Maybe we can put that together up here. So what did we just say? Speeding up, what do you observe about the acceleration and velocity arrows? Same direction. How can we say that up here? Patty said they're in the same direction, and I agree. But I don't want to write out the same direction because that's a lot of words. But I put A times B is greater than 0. Does that say the same thing? They either both have to be positive or both have to be negative. So you have to be both pointing that way, or both pointing that way. Cheers or something. What about slowing down? What did you observe about that one? They have to be opposite directions. So how can we state that algebraically?
A times B is less than 0. Oh gosh. Oh, these kids are... These kids always talk.
Excellent. Okay. I think I'm about out of time almost. Got 1 minute? Okay. So here's the online on Moodle. On Moodle, I have posted a page with the assignment, which is, the assignment is, on Moodle you will find a note sheet on this kind of terminology we're just going over. So you should read that. And then you'll also find on Moodle a lab that we're going to do in class tomorrow. The lab tomorrow will be several of these graphs like this one, others, and you'll be in groups, and you'll have to have someone tell me how the walk should happen, and somebody else has to walk the walk. Are we clear? So you don't know which one you're going to have to do, so you need to know how to do all of them. And then I'll call on you randomly who's going to do which one. So the homework It's not in the book tonight. You got some reading to do, and you got some thinking to prepare for your lab, which is going to be graded. That lab tomorrow will be graded in class, so be ready. See you tomorrow.
Do you want us to print off the lab?
I would encourage you to print it off, yes. Or if this cleaner will print it for you, that's fine. You don't have to, though. I would encourage you. Because I'll try it for you. But you don't want to look at it, so you may want to print it tonight.
We have to still keep on until our homework is gonna be created.
It's all great.
Sammy, you got lucky today. Sammy? You got lucky today. Ran out of time.
You escaped the handout, Jonathan.
Don't forget to post your video of Rezo.
Where do I post it at?
Go to the discussion forum on Moodle. Go to the discussion forum on Moodle. I posted there.
Okay.
Want to see it?
Does anybody want me to print this off? It's 2 pages. Anybody want it?
I can do it when I get home. I got a printer.
I can print it down.
I got a printer. Oh yeah, Klinger, did you ask him the question? Yeah.
Yes, I did, and he said he'd meet us there. Ask him now.
Wait, what?
Wait, what?
That's a contest.
No, I was talking about the shorter teacher. With
What was the other question?
the chemistry teacher here?
Oh, I haven't talked to him yet.
Okay.
But Dale said he would come to the math competition
That's pretty awesome.
and meet you guys.
Yeah.
So there's that. I did ask Dale that.
Miss Quaker, for the test, I watched like 6 hours of Khan Academy videos. It helped.
Did you get it? Do you have any questions about it?
Not really. I just missed points on like the explanation part, and that's it.
Excellent. That's cool.